Thank you, Mike, for the introduction. We've been talking about payment preventive maintenance, also payment asset management, but in my opinion, without a good foundation, you don't have much to management or to maintenance. So let's talk about the foundation. My topic is about intelligent compaction. I'm going to talk about why do we need intelligent compaction. So what is intelligent compaction? So what information does intelligent compaction provide us? How do we use the information we've been collected using intelligent compaction technology? And how much benefit we can get from intelligent compaction? And also intelligent compaction resources. If you have you need information, you can go either ask me or go online. So I'm going to talk about that. So before we talk about that, let me ask you, how many of you have ever heard intelligent compaction? Very good, very good. So let's talk about. So why do we need intelligent compaction? So before we are able to answer this question, then we're going to ask ourselves a couple of questions first. The first question is, what are the key characters for good compaction? I'm going to focus on soil and base compaction. So we are not interested using intelligent compaction on hard mix, although other states, they do intelligent compaction on hard mix, but we are not focused on that. So what are the key characters? Can you give me some examples or thoughts? So we are looking for high compressive or shear strength, of course, right? So we're looking for strong compaction material. Then we're also looking for higher stiffness or modulus, low permeability, low swell and shrink, also called volumetric stability. Of course, low settlement. What are we missing here? Think about. I'll give you a hint. Why do we have a pothole here, not 100 feet away? Why we don't have a pothole everywhere? We have some localized area. Homogeneous, or uniformity and consistency. We are missing that. To me, that's the most important characters for good compaction. So how do we get that step? With the current practice, no, there's no way we can get that because we only do a density control or I call spot check. Regardless how many tests you're going to do, it's still a spot check. So the question is, do we know for sure a good compaction has been achieved? Well, sometimes we do, but most of the time I think we don't. We don't even know the rest of the area we already get compacted or not. We only know the specific area, very small area, then which we tested. We know that area, we reach the density. For ordinary compaction, we don't even have that. So we're assuming the rest of area, maybe 99% of the area, at least the same density as the area you tested. Sometimes it's true, but we don't know that. That's why we need intelligent compaction. So can we do a better job? Yes, with the intelligent compaction, no doubt. So with the intelligent compaction, as the name implies, intelligent compaction is a smart way to do compaction. It's an easy way, it's a simple way, if we can do it. Intelligent compaction, I call it is an engineering-based compaction. We talk about performance-based, engineering-based. It is an engineering-based compaction. So what we have been doing now, I call it a blind compaction. I don't want to call other compaction rather than intelligent compaction, but it is a blind compaction. It's an experience-based compaction. Why? Because although we call it density control, we don't really control anything while we're compacting the material. Because we only check the density after the compaction is complete. During the compaction, you don't have any control. So what is intelligent compaction? So in order to do intelligent compaction, you have to have three components. You have to have a vibratory roller that is equipped with some kind of stiffness measurement device. That device continuously measures the stiffness, sometimes not really stiffness, but we call it stiffness-based parameters or whatever numbers, indicators. They also report that stiffness data in real time, paying attention in real time while you're doing compaction, not after, not before, during compaction. And a second component is you have to have a GPS documentation system. That's going to give you the location of the rollers in real time. You're going to see that. I'm going to talk about that. And the third, that is the third component, is a computer on-board display panel with a color-coded map. So the roller operator can see the map while he's driving the rollers. Then he will be able to see where he has been compacted, where he has not, how many passes he has been compacted. Has he reached the density, not the density, the stiffness or not? So this is nothing to do with the density, okay? It's stiffness-based measurement. So let's see. So here's the three parts, the computer onboard display panel here, so the GPS receiver here, then accelerometer, which measures the stiffness. So it's just a vibratory roller with those three extra components. Right now, there are at least six roller manufacturers. They have intelligent compaction rollers. So as you can see, the Caterpillar, Dynapack, Bormac, Sakai, Case, and Ham. But in addition to these six big roller manufacturers, we also have, we call it a retrofit, intelligent compaction retrofit kit. So in fact, the textile construction division, we already bought 2 sets of retrofit kit. So if you want to try that, let me know. So then I can work with you. Then we needed to try those retrofit. So those retrofit, the idea is the real, I call it market-ready intelligent compaction roller. Normally, it's going to be 30 or 50% more than the regular rollers. I talk about the new rollers. So it's expensive. So the retrofit kit is going to give you another option, which is lower your cost. So basically, you just, same thing. You have the GPS receiver. You have the display panel, the computer display panel. You have the accelerometer. So you can have a regular vibratory roller that you mounted these 3 devices. So you do the same thing. You do the same work. So this is a retrofit kit that we bought. So this is the outside, looks like. This is the inside. Basically, they have those components. Display panel, accelerometer, device, and the GPS antenna. So what information the intelligent compaction can give us? They give us 2 sets of information, 2 sets of data. One is the pass count. Since you're using GPS receiver, GPS documentation system, they give us the pass count. They tell you how many passes you already been there. You will not imagine, how well, even a very experienced roller operator is gonna forget how many passes they already done. You'll be surprised. They also give us another set, it's called stiffness. So you can see that on the computer display panel, on-board display panel. This is one example. This is a Ham technology. You actually can see both at one time. You can see on the left, this is a pass count. Based on the color-coded, so the first pass is color-coded as red, the yellow like 4 passes, so you can clearly see that on the board. The stiffness is another one, also color-coded. 0 stiffness is red, green, getting to yellow and green is much higher stiffness. So you can see on this, you can switch back and forth, either pass count or stiffness. You can do on this ham, or you can see both, but other rollers, you can switch back and forth. After you get the data, how do we use the data? So we get a whole set of data, then we already have a specification, then we set up the criteria, then you can, using those simple criteria, then generate a color-coded map. Basically, we're using 3 colors. It's yellow, green, yellow, and red. Green is a high stiffness. The red is a lower stiffness. So that's the color-coded map. This is the color-coded map I generated using real data collected from FM 450, which is in Atlanta district. Then we also be able to import the design alignment file, so which consists of the station number. You can see here, 525. Normally those folks working in the field, they like station numbers, not like GPS coordinates. So we can color-code it, make a color-coded map with the station number. So basically, how do we use this color-coded map? So we see the red area, which is maybe for some reason not compacted well. Or if you try to get a color-coded map for pass count, you will know where the red area has less pass count, less pass. So for this time, you see the CMV means the stiffness. So you have the red area, which is the lower stiffness. So we're going to using this map to guide our textile inspector to check the density. So right now, our specification still specified the density as acceptance 2. So this is only for quality control, not quality acceptance. So we can say, OK, let's check here the red area for some reason. Or maybe we can check the green area too to see some, is there any something wrong over there? So sometimes we don't want to compact it too stiff. There's a reason. So we don't want it too stiff. So either way, too stiff or too weak, then we can check. Using the nuclear density gauge, check the moisture also. So what the benefit we can get? I listed here, there's a bunch of benefits. I just list the major point here. So our intelligent compaction can provide us uniformity information, which we don't have before. Okay, I mentioned that before. The intelligent compaction can cover 100% of the area you're compacting, and track the roller location and counting the pass count. Identifies area of under or over compaction area, like the color-coded map. Contractor can using the onboard computer display panel. That is another color-coded map on board on the roller. So monitor the compaction process in real time during compaction. So if you see some area he has not compacted or some areas still weak, he can go there do more compaction before he completes the compaction job. Then improves the productivity and minimize the cost, basically a rework or redo job. IC also provides a performance-based information, which is basically the stiffness or modulus, then which can better link to a mechanistic pavement design. For those of you who do pavement design, you know we're using stiffness or modulus to do our design. We're never using density to do our design. There's a gap between density and the pavement design. So in this case, we can get the stiffness in the field, so we can use that information to do a better design. The last but not least, IC also improves the construction zone safety, the safety in construction zone, by reducing the staff working in the field, doing spot checks. Eventually, I hope we can get rid of the nuclear density gauge or any other spot check, like a DCP, like a LWD, whatever test. That's a spot check. So I hope we can get that. Without your help, then we can get that go. If you need more information, there's a website called intelligentcompaction.com. That's a one-stop shop. Then you can find out everything, all the projects happened not only in Texas, in the nation. All these projects, data, the report, everything is there. Or if you need help or still have questions, you can call me. That's my number and email address. So I hope, after this presentation, if you're interested, feel free to call me, then we can work together. We can better using our retrofit kit, since we already bought two right now sitting in my office. So thank you.